Alright, I'm back. So, I haven't uploaded at all regularly. I can't speak today. I have not uploaded regularly in a little bit. Reason being, I've been working on all of this. So, this is kind of like the shining achievement that I've got here. If you could not tell by the video title, I made a computer in Minecraft. Yeah. So, I'm basically going to be showing that off, showing a bit of that off. Actually, we might do that area first, just so I can give you a linear timeline of how all of this worked out. So what this does is, it's very simple. I have not actually gotten it as advanced as I want it to be. This is kind of just like a prototype for future endeavors, but it's going to be good. So this is a calculator. It's a simple calculator with a screen, a 16 by 9 screen. So these two buttons are gonna, well, not buttons, but levers are gonna be controlling it, and I'll get to that in a second. But first, for this story to work, I need to show you something. Ignore that. That was kind of me testing something out there. And ignore this. This didn't work. That was supposed to be the first screen. It didn't work. Also ignore this. Ignore a lot of this, okay? Don't ignore this, because this right here is the first part. So, about 2 weeks ago, I started learning how circuits worked in Minecraft. As you can see here, I have a couple of examples. This right here, this is what's called an AND gate. First input and the second input must be on for this to come on. So let me just show you that real quick. Obviously, nothing happens. But both of these on will turn this on. As you can see, if I just have this one on, it won't turn on. This is a simple switch. It's just a switch. However, it's used for making more complex gates. Turn this on, this turns off. Turn this off, this turns on. Simple. Now, this is more of like a selector. So it selects which one of these two right here will turn on this. So I have some signs over here that will say it. This being A, this being B, okay? And that's A, that's B, but I destroyed it. That's not what I meant to do, but whatever. That is A, that is B. So currently I have it selected to B. So if I turn it to A will be able to turn this on. However, if I switch it from A to B, A won't be able to turn this one on anymore, but B will be able to turn it on. It'll be able to turn it on. Turn it on. I'm funny, I swear. Alright then. This is just a more organized version of that one, where the switches are closer, so that it's easier to do it. Yeah, I destroyed it over there because of all of that's happening. This right here is the first version of that thing over there, which is what I showed you at the beginning of the video. This right here is a 4-bit calculator, capable of doing 4-bit processes. Well, I say processes, it's really only one process, which is addition. So the way this works is quite simple. Go over to this one, okay, these are the ones, okay, this is A1, B1. These are the 2s. This is A2, B2. These are not the 3s, these are meant to be the 4s, so I will fix that later. These A4 and B4. And these are not meant to be the 4s, these are meant to be the 8s. What was that? Alright, whatever. A8, B8. That looked like a 9 for some reason. So, it's very simple. It converts the numbers that you put... Oh, I destroyed it. It's fine, everything's fine. Okay, I got lost there. Let me just fix this. Here we go. B2. There we go. Alright. So it converts the numbers that you put in to binary. It's an addition. It's a calculator that can only do addition, basically. So if I put in, say, 1 plus 2 plus 4, we get 1, 1, 1. We're ignoring this number right here because we're not using either of these two, so you ignore that number. And we just pay attention to the first three, since that's what we're using. Son, don't you dare go. You think you're gonna go down. You think you're gonna go down, but no. But no. Yeah, that's what I thought. Anyways, so this is 1, 1, 1, which converted into decimal numbers, 111 is the code for 7, which, if you do the math yourself, 1 plus 2, which is 3, plus 4, 7. So, using logic, it actually figures out that these specific inputs equal this code, which equals 7. Now, this is all well and good, okay? You can use this for up to the number 15, this specific one. However, I didn't want to stop there. I wanted to go further. This right here is just, this is select. This is just for introducing a 1 at the beginning. So ignore that for now. I wanted to make something a bit more powerful. So I didn't put a case around this one because I just didn't feel like it. But this is basically what it looks like on the inside, except a bit smaller because this is 4-bit. This is 8-bit. So these are the same displays, but instead of 4, we get 8. Same principle right here. Let's say 1 plus 2 plus 4, which equals 7. 1, 1, 1. However, this one can go a bit further. Let's say I wanted to do a bit more advanced math. Honestly, this is just addition, so it's really not that advanced. So, if I wanted to do, say, 128 plus 64, we would get this, 0, 0, 0, 0, 1, 1, 0, 0. Now, in binary, I forgot what that is. Hold on, wait, what? Okay, so 128, 4, 132 plus 60, 192. Okay, so it's 192. But as you can see, besides the fact that it's binary and it doesn't say a decimal number, it's actually faster to use the calculator than to math it out yourself, which I personally think is very cool. I don't have a tutorial for this, and I'm not going to in this video. If anyone wants a tutorial video, then let me know. I can do that. But behind here, behind the binary display, is this mechanism. This is storage. Now you might notice 2 of these lights are on. Well, that's because the last calculation we did was then saved. So it's kind of like a very basic storage method. It's not really like how you do it in real life, obviously, but it's the Minecraft equivalent of a hard drive. A very, very big hard drive and very, very inefficient hard drive, but a hard drive nonetheless. As you can see, there's spacing here for each slide. So I haven't finished the ones down here yet, but I will. So I'm going up here. You'll see there's a button right here. This deletes all the data on it. As you can see, those are no longer lit up. So I will basically be taking this and putting it down there as well, so that you can store all of the binary numbers from here back here, so that you'll have your answer from previously in case you forget it or something like that. I don't know. It's pretty cool. So those over there, those are just basically bigger and more, I don't know, have more capacity than this version right here. Let me show you that one. This was the first one I built when I was just learning how to do it. This one is 3 bits, so you can store exactly 3 bits of data on this. Impressive, I know. So back here you have the displays that tell you, hey, you're storing bits. So this is slot 1, slot 2, and slot 3. Each slot can hold 1 bit, and up here you have the controls. So this is delete all the data on slot 1, and this is store all the data on slot 1. So if we go back up here, you will see I have stored 1 bit of data, a 1 and a 1. Now this could be a 0, this could be a 1, and you know, vice versa. However, I haven't quite figured out how to store it to just one of these at a time. I think for that I would need to make an entirely new button that stores a 1 and a 0 or a 1 and a 1, something like that. But as you can see, if we press this, it mechanically removes the data. And of course I could basically just have this loop around and then come up here so that you could see it better. Maybe at some point I will do that. This is the same thing, just a little bit more organized. And as, yeah, basically just the same thing. Same outputs, all that. So now we get to the cool part. Ignore that. That was just me being bored. Now we get to the cool part. This right here is called an adder. Specifically, this is a full adder. A full adder is just basically a logical core of sorts. It's not a core if you're a tech person like me. It's not a core in terms of like a CPU core or anything like that. And honestly, it's probably not even called this. This is probably just a name I came up with randomly at some point. But I call these bit cores. Again, probably not the actual name for them, but that's what I'm calling it. So these are bit cores. This is what powers the calculator there, the calculator behind that one, and the calculator here. So if you see, if I put in it works same as that one, by the way. 1, it'll output this. It'll output to this. Now this right here is basically the Minecraft equivalent of a pixel. Now the reason there's 4 lamps rather than just one standing for 1 pixel is because you can't actually stack a pixel on top of a pixel and then control just one of them. You can't do that. So instead 4 of these have to stand for 1 pixel. And so you can control it individually. Let's say if I have this like this and it's a 1 and a 1, 1 plus 1, it actually doesn't turn on. Reason being, a full adder does not actually have the logical processing capabilities to process that much data. It can't process 1 plus 1. It simply it doesn't have the processing power for it. You would need a second adder in order for it to work like that. And that's about carrying out and all that, but I'm not going to do that in this video because that's not the purpose of this video. I'm just showing you what I've made. And again, if anyone wants a tutorial on how to do this stuff, I can do it. It's pretty easy. I learned through YouTube tutorials as well. You could do it too. Yeah. So this is the shining achievement of all of that work right there. This is a, as I said before, 16 by 9 screen that will display an answer of any equation you want. So I have this wired. Let me show you how it works specifically, wiring wise. I have this wired to come all the way here. Now these are just like that, except there's 2 of them now. So there's one right here, gold line in the middle to divide the 2 adder cores. So this is the input. Now I haven't done this one because it's actually, I just didn't want to, I wanted to wait a bit because as you can see I have the pixel machines lined up very specifically to show one number or another number, basically. So let's just put in a 1 plus 0, a 1 plus 0. Give it a second. Boom, 1. Yep, there we go. So 1 plus a 0 equals a 1. But we can go further. Let's go. 1 plus 1. Boom. Now 1 plus 1 does not equal 10. 1 plus 1 equals a 1 and a 0 in binary. Okay, so 1 standing for the 1, the 0 standing for the carry out. So, boom, that's basically it. It displays the binary number. Now, of course, I could make it so that it shows the actual decimal number, but it's very difficult, which, third time now, if you want to see a tutorial, I could turn this into a series of some sort where I show y'all how to do it. So, as you can see, by the way, it works for both of these. Let it update, and boom, there's a 1. Doesn't really matter which one you use. As you can see, it doesn't. It doesn't update very quickly because, again, it's a very slow way of processing it. all these repeaters kind of slow it down in terms of Minecraft ticks. And then of course it doesn't have the most processing power in the world, has to process all of this, etc, etc. So yeah, if you enjoyed, please do leave a like, it is appreciated, and I will see you in the next video.